Okay, this was the hypotenuse leg assignment we did in class the Tuesday before Thanksgiving. I believe that was November 20th. Okay, the first problem asked us to determine if we can use each of the following four postulates to prove that these triangles are congruent. Okay, the first thing we need to do is take what's given and also add in our shared sides or vertical angles. So we have vertical angles. Angle NML is congruent to angle PMQ. Okay, so they're vertical angles there. So we have four congruent parts. Let's see if we can match them to any of our four postulates. So angle, side, angle. Okay, cover one of the triangles up. Do we have an angle, side, angle? Yes, we do. Angle, side, angle. We can go in order and have an angle, side, angle. So this one's yes. We can use angle, side, angle. Can we use angle, angle, side? Well, again, if we go in order, right, we can use these three. Okay, we have angle, angle, side. So yes, we can. Okay. Can we use hypotenuse leg? Okay. Hypotenuse leg requires three things. It requires right triangles. Do we have right triangles? Yes. If we have right angles, we have right triangles. It requires a pair of legs to be congruent. So do we have a pair of legs to be congruent? Yes. MN and MP. We also have NL or QP, right? So these would be our legs. So for hypotenuse leg to work, we need right triangles, which we have. We need a pair of congruent legs, which we have. In fact, we have two pairs of congruent legs. And then you also need congruent hypotenuses, okay, which means we would need ML to be congruent to QM. Okay, but there's nothing in this diagram that would tell us that ML is congruent to MQ. So we cannot say that the hypotenuses are congruent. Therefore, we can't use hypotenuse leg. Okay, and then side, side, side. So again, we have two pairs of congruent sides. We would need the third side to be congruent. And again, there's no way for us to tell that ML is congruent to MQ. We can't just assume it by looking at it. We can't just assume it's true. We can't assume that M is the midpoint. We have to use what is given, and based on what is given, there's no way for us to determine if that third side, third pair of sides is congruent, so we cannot use side, side, side. Okay, 5 through 10 is asking us if there is enough information available to prove that the triangles are congruent using one of our 5 theorems or postulates. So we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So we have to use one of those 5 to prove they're congruent, or to show that they are congruent, if possible, if there's enough information. Number 5, again, we can use reflexive or vertical angle because that's part of the diagram. But that's about all we can tell. All we can tell is that we have two sides that are congruent. We can't tell any angles. We can't tell the third side. So there's nothing more we can do. So all we have is side, side, which isn't going to be good enough for any of our postulates. So we have to say there's not enough information. Number 6, we have an angle, we have an angle, we have a side. So we can use angle, angle, side. Right, so those triangles, triangle QRP and triangle JKL, are going to be congruent. 7, and we can use reflexive property just by looking at the diagram. We know TU is congruent to TU. So here we have an angle, a side, and an angle. So we can cover up one of the triangles. Is this an angle or a side? That's an angle. Is this an angle or a side? That's a side. Is this an angle or a side? That's an angle. So we have angle, side angle. Okay. Number 8, again, reflexive. Put those dashes in there. We know HF is congruent to HF by reflexive, or we know HF is congruent to FH by symmetric property. Okay. If we cover up one triangle and just look at one, we have an angle, a side, a side. Is angle side side one of our postulates? No, it is not. Okay. So since we have right angles, we know we have right triangles. So let's look and see if we have hypotenuse leg to show that they're congruent. So we have right angles. Let's check. So right angles, check. We have a pair of congruent legs. Yes, we do. Legs are congruent. And do we have hypotenuses congruent? Yes, we do. Okay, so EH and FG are legs. So again, leg, 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 leg. And then a hypotenuse is the same. The hypotenuse is, for both of them, is HF. So since HF is congruent to HF, our hypotenuses are congruent. Since we have a pair of congruent legs, EH and FG, and since we have right triangles, we know by the hypotenuse leg postulate or theorem that triangle FHE is congruent to triangle HFG. Okay, number 9, again, vertical angles are here. The parallel lines tell us that we have alternate interior angles here and here, and also here and here. This little symbol here tells us RS is congruent to VU. So here we have angle, angle, side, or we can use angle, side, angle. Number 10, we have a shared side. So again, we can use angle, angle, side, or we can use angle, side, angle. That would work in both of those situations. Okay. Now we have the 2 proofs. We went over one of them in class, but I think we went over different ones for different classes, so I'm just going to go over both of them. Okay, so the first one, it's all on there. Okay, so we have steps, justifications. Okay. So we have 2 givens, angle PRS and angle RPQ are right angles. And then we have that SP is congruent to QR. Okay, these are given and given. Okay, and they already have it drawn in for us. So SP is congruent to QR, and then angle PRS and angle RPQ are right angles. Okay. So in our proof, step 1 is write the givens. We have the givens written. Step 2 in the process is going to be look for shared sides or vertical angles. We do have a shared side. PR is part of both triangles. So we can put PR is congruent to PR by the reflexive property. Okay. If you put PR is congruent to RP, that's even better. But you would have to use the symmetric property. Since the symmetric property is not on our reference sheet, I'm just sticking with reflexive property in all situations. So PR is congruent to PR by the reflexive property. So step 1, write the given. Step 2, look for shared sides or vertical angles. Step 3 is use our givens. In our normal process, when we are given 2 right angles, we use the right angle theorem to say that right angles are congruent. Okay, here's our PR is congruent to PR. So we would say that since we have right angles, and we know by the right angle theorem that right angles are congruent, we would say angle PRS is congruent to angle RPQ. Okay. The problem here is that would leave us with angle side side. We cannot use angle side side. It's not one of our postulates. Right? You can have two triangles that have congruent sides and a non-included angle that are different sizes and shapes. So you cannot use angle side side to prove that the two triangles are congruent. Okay, you can have two triangles that have two sides that are congruent and a non-congruent angle that's congruent, and not have the same size and shape triangles, not have congruent triangles. So instead of using angle side side, which we can't use, okay, and since we have right angles, we want to look to use hypotenuse leg. Okay, the definition of a right triangle on your reference sheet, if you look for the definition of a right triangle, it will tell you a right triangle is a triangle that has a right angle. So if angle PRS is a right angle, triangle PRS is a right angle. If angle RPQ is a right angle, triangle RPQ is a right angle. So these two are right angles because a right triangle, as defined on your reference sheet, is a triangle that has a right angle. So if you have a right angle, you have a right triangle. Okay. Hypotenuse leg theorem says if you have two right triangles, which we do, we have two right triangles. If you have two right triangles whose hypotenuses are congruent, do we have congruent hypotenuses? Yes, we do. SP and QR, these are hypotenuses, and they are congruent. And we also need a pair of congruent legs, which we have in PR and PR. So we have a pair of congruent legs. So since we have right triangles, the hypotenuses are congruent, and one of the pairs of legs is congruent, we can conclude by the hypotenuse leg postulate or theorem that triangle PRS is congruent to triangle RPQ. Because if you have right angles and hypotenuses that are congruent and a pair of legs that's congruent, there is no other possible way to prove, or there's no other possible ways to make a triangle out of that information than for those triangles to be congruent. There's no second possible size or shape you can make a triangle. If this is not a right angle, then you can make different shapes. So you can have different triangles, different sizes and shapes for your triangle. So this is like angle side side, it's a special case. If it's a right angle, if it's a right triangle, then you can use what essentially is angle side side. But that's only when it's a right triangle, and instead of calling it angle side side, we are calling it hypotenuse leg. Okay. So that's the first proof. Okay, let's go to the next proof. This one has 3 given, so again, first step in the process to write the given. So BD is congruent to FD. D is the midpoint of CE. And angle BCD and angle FED are right angles. And that should jump out to you. Since this is about hypotenuse leg, we probably are going to say that triangle BCD and triangle FED are right triangles. Okay, that should jump out at you right away. Okay, but let's follow the process. Step 1 in the process is to write the givens. We've written the givens. We had 3 givens. We wrote all of them. Step 2 in the process, is to look for shared sides or vertical angles. We do not have any shared sides or vertical angles. Okay. Step 3 in the process is to use the given. So our first given already has a congruent piece. So we already have corresponding pieces that are congruent, BD and FD. Okay, so let's use the next one. Second given is midpoint. If we have midpoints, we're looking for congruent segments. Okay, the definition, again, on your reference sheet, a definition of midpoint tells us that D, point D, since D is the midpoint of CE, it cuts CE into 2 congruent segments. So D is going to cut CE into CE, 2 congruent segments, CE and DE. We know they are congruent based on the definition of our midpoint. Okay, again, in our usual process, if we have right angles, we are looking to say they are congruent by the right angle theorem. But again, just like in the last problem, we run into the same issue. It would be angle side side. We do not have the angle side side postulate to prove that triangles are congruent. So if our goal is to prove triangles are congruent, we can't use angle side side. We need to have a different approach. That different approach is noticing that we have right angles. So we can try hypotenuse leg, because for hypotenuse leg, you have to have right triangles. In order to have right triangles, you need to have right angles. So just like in the last one, the definition of a right triangle says that a right triangle is a triangle that has a right angle. So if we have a right angle, we have a right triangle. So BCD and triangle FED, triangle BCD and triangle FED are right triangles. Okay. We know they're right triangles because they have right angles. So a hypotenuse leg theorem, hypotenuse leg postulate, says that if you have right triangles, we have right triangles, that have congruent hypotenuses, we do have congruent hypotenuses, right? Our hypotenuses, here's our legs. Okay. We have congruent hypotenuses, and we have one pair. We only need one pair of congruent legs, and we have it. CD and DE. So right triangles, hypotenuses are congruent, a pair of legs is congruent, therefore we can conclude that triangle BCD is congruent to triangle FE. Those are the 2 proofs for hypotenuse